Okay, this is notes 1.2, defining limits. So remember, when we are trying to find a limit, we have to word it in a certain way. So if we were using the function of f of x, and let's say we were approaching the value 2, we would say as x approaches 2, f of x approaches 1. And we're going to see that in these examples down here. Okay? So we have the first example. And again, we're looking at the limit as x approaches 2 of f of x. And when we're trying to find that value, first I like to look at 2. So 2's right here. Okay, and then the next thing I like to do is I like to look at it from both sides. So I'm looking at it from the left side and from the right side. So notice that both sides approach the same value, and that is 1. So the limit as x approaches 2 of f of x is equal to 1. Now let's find f of 2. Well, f of 2 is just the point at x equals 2, so right here, and that is also 1. Okay, let's look at this one. This one says the limit as x approaches 2 of f of x. So I do the same thing. I look at 2. And notice here I now have a hole there. Okay, you'll soon find that a hole does not matter because a limit is not asking us what the value is. It's asking what the value is approaching. So if you look at both the left and the right side, they're both still approaching a 1. So this is going to be 1. However, since there is a hole here, we cannot find a value for f of 2. Okay? When there's a hole there, that means it does not exist at that value. So we say f of 2 is undefined. Okay, and then lastly, okay, we have a hole, but we also have a point above that hole. So you'll notice that the limit doesn't change. We're still looking from left to right. We still notice that it's approaching 1. But now f of 2, since there's a hole there, if we look up at this spot right here, f of 2 is actually that value 3. Okay, if there's a hole and another point that is going to cover that hole, then that value is going to exist. And at this instance, it's f of 2 is going to exist at 3, equals 3. So just a reminder, that a limit is a y value that a function approaches. Sorry, excuse me. Okay. And a limit may or may not be the same as the actual function value. And we see that here. I'm going to highlight it, match it up. We see that here in this example. Okay, so just because our limit was 1, that didn't mean f of 2 was also 1. So that was a good example of that. And also the next one is also a good example. Okay, so let's look at some examples here. It says use the following graph to evaluate each problem. So let's start with the first one. It says the limit as x approaches 1 of f of x. Okay, so 1, so I'm going to look here. Okay, so since it's approaching 1, we have to look from the left and the right side. Okay, so notice from the left side and the right side, they are both approaching -1. So that would be our answer. Okay, let's look at the next one. So we're looking at the limit as x approaches 2. Okay, so again, looking at the left side and the right side, notice that they are both approaching 2. I'm going to do all the limits first. So let's look at this one down here. So we're looking at 0. So the limit as x approaches 0 of f of x, I look at the left and I look at the right, and notice I get to the same value of -2. Okay, let's add another color here. Let's do this one. This is at -3. Okay, so I'm looking at the left, looking at the right. They are both approaching 1. Okay, so now I have to look at all these other values. So I have f of -3. Well, f of -3 is here. And notice I have a closed circle on 0, so that's my answer. F of 2, I have a closed circle here, so that's going to be 3. F of 1, right here, there's an open circle, so this is undefined. F of -2 is right here at +2. And that's us filling in all of the problems. Number 9 says, give an interpretation of the statement, limit as x approaches 7 of f of x equals 10. So all this is saying is that as x approaches 7, the y is approaching 10. And I'm going to emphasize from both sides. And we'll talk about that more in the next notes. So it says a limit does not tell us the value of f of x. It just tells us what the function approaches. So it says f of 1 is always equal to the limit as x approaches 1 of f of x. That is false. F of 1 is never equal to the limit of f of x as x approaches 1. That is also false. Okay, so showing you some examples that we talked about today, why these would be false, is remember, we could have a function that has a hole with a point above it. We could have a function that is continuous, no jumps, no holes, and has a point there. And then we could just have the function that looks like this.